This video introduces a Trinity use case focusing on robotic welding and additive manufacturing using a robotic TIG welder to increase flexibility in production systems. In this video, we'll present how this use case contributes to increased agile manufacturing, the benefit of the use case, where the use case can be applied and used, and what investments are required. So how does this use case contribute to flexible manufacturing? It introduces a fast and straightforward method for programming of the system, which allows for more changes to the program and again increases the flexibility. The system can be programmed and monitored remotely, which gives you an agile method to have control and overview of the system. The current setup of the use case uses a TIG welder. However, the same system can also be used with a MIG welder. The system can be used to repair parts that have suffered wear and tear over the years. The benefits of this Trinity use case. So the benefits for the first module in this use case is called simulation welding. And the benefits are: reduce the time it takes to reconfigure and program a system. You can verify the program before running it on a physical robot, so-called offline programming. It releases humans from labor-intensive and heavy work. The second module is called Additive TIG Welding, and the benefits for this module are cost-effective alternative to large and expensive 3D metal printers, being able to repair parts such as a broken gear wheel, significant cost saving due to reduced material used, reduced production time, and reduced number of parts in assembly using the system as a 3D metal printer. Application scenarios. So this use case can be used in factories or production systems which require rapid reprogramming of the welding robots. This use case can be integrated to various companies dealing with product assembly. It can also be used by SMEs to help the operator reduce the training and make the interface with the robot simpler and more intuitive. Investment. When it comes to software, this use case uses Visual Component Premium, which is a manufacturing simulation software. In this case, we use it to program and set up the system. There are also other software used in this use case. However, these are all open source. When it comes to hardware, it will be sufficient to have an old industrial robot which can be controlled with an external computer. However, a rotary table can also be added. This is to give the robots more freedom and more movement to do more advanced welds. So in conclusion, using an industrial robot for welding and additive manufacturing can increase flexibility and agility. And using a simulation software for programming can reduce the programming time and complexity. The simulation software allows for testing of the robot program before executing it on the real physical robot. This system can also be a cost-effective alternative to large and expensive 3D metal printers. Thank you for watching this Trinity use case introduction. If you are interested and would like to find out more about the training material for the modules, take a look at the Trinity website for more information on the use cases, modules, and training material.